Okay, so good morning. This morning we begin with VRRP principles and configurations. So we want to understand what VRRP is and how we can configure it. Now, as the forward, user terminals. So these are user devices on a local area network, often access the external network through a configured default gateway. So even on ENSP, I'm sure you've seen the gateway field when configuring the IP address. So most of the time, if they want to get to any other network, you have to configure a default gateway, which is the IP address of the interface of the router that is connected to that network segment. Now, if the default gateway fails, then network access of all the user terminals is terminated. Now, consequently, there will be huge loss. So you can deploy multiple gateways to solve this problem. So one of the options is to deploy multiple gateways in order to solve the single point of failure. So how do these then gateways work collaboratively without conflicts? Now, VRRP is used to solve this problem. It can implement gateway backups and also prevent conflicts of multiple gateways. So how is this done, and how can we configure VRRP on our routers? So by the end of this chapter, you should be able to, Owen.
Upon completion of this section, you'll be able to master VRRP principles, understand the VRRP active standby switchover, master VRRP configurations.
Very well. Okay. So let's begin with a background and an overview of VRRP. So one of the limitations of a single gateway is that it introduces a single point of failure. Now, just to say it again, when you're configuring these devices to be able to access the internet, you need to configure them with what we call a gateway. And the gateway is simply the IP address of that particular interface that is interconnecting, that is connecting to that network segment. Now, as you can already see, if there is a problem with either a link here or this particular interface, then all these people are going to be isolated. All these people are going to be isolated. So that is one of the problems with using a single gateway. Now, as you can see, so all traffic to the internet is going via router A, which is our gateway. So if router A is down, then boom, no one is able to access the internet. Now, one of the solutions to this is implementing multiple gateways. So these again provides new challenges. So one of the problem is that we might have IP addresses of gateways conflicting, and also hosts may frequently use different egresses. So egresses is routers that are helping you to get out of your network. So really, that is one of the problems that we might have with multiple gateways. Okay, so let's look at the overview of VRRP. So generally, how VRRP works is that it virtualizes multiple routers into a single virtual router without changing the networking, and uses the IP address of the virtual router as the default gateway IP address, thereby implementing a gateway backup. Now, we have two versions of VRRP. Commonly used is VRRP version 2, but we also have VRRP version 3. The main difference between these two versions is that VRRP version 2 is for IPv4 networks only, but version 3 then was created to take care of IPv6 networks. So it's able to support IPv4 and also IPv6 networks. Now, as we're going to say, VRRP, just like many other protocols, uses packets. So we have advertisement packets that are sent by VRRP, and they're normally sent to the multicast destination address 224.0.0.18. Now, as we know, we also need a multicast MAC address, which is usually created by VRRP. As you're going to see, these particular bits actually are normally just like that, so they never change. Then, as you're going to see, we're going to create different VRRP groups. So these two last bits actually represent the particular VRRID group ID. So generally, these ones are going to remain like that, but this one is going then to be taken from the VRRP group ID. Now it uses the protocol number 112. So on the type field, it uses 112. Now let's now look at the architecture of VRRP. So there are several things that we are supposed to understand here in order to know how this works. So let me just press next so that we can have everything here. Okay. Now, the first thing we strive to understand here. So generally, as we've already mentioned, with VRRP, we're just combining several gateways into a single logical gateway. So this here is the physical architecture, how our devices are interconnected, and this is our logical topology. So this is a logical topology. So what we're simply doing here is combining router A and router 2 into a single logical router called a virtual router. Now, as you can already see, normally when we are configuring these routers, we configure them with what we call the priority. So for example, we have a priority of 150 there, and a priority of the priority of 100 here. Now generally, this value can range from 0 all the way to 225, but the default value is 100. Now, how the router chooses between what we are calling here the master or a backup is by considering the router with the highest priority. So it makes the router with the highest priority the master. So what the master means is that generally traffic then is going to be forwarded through this particular router because it's the master. Yeah? And if this guy fails, then traffic is going to be forwarded via this other router. The backup is going to be the new master. So generally, that is how this works. Now, the virtual router that we're talking about here, the virtual router, so this is what we're seeing here, can have a single master. It can only have a single master, but it can have multiple backup routers. So what I'm just saying is that we can still have another router connected to this network segment, but all of them are going to be combined into a single logical router. So that is what we call a virtual router. Now, the other thing we need to understand is what we call a VRID. So for example here, you're going to see we have a command called VRRP VRID1. Now, VRID is the virtual router identification. And normally, this particular value is manually configured in order to uniquely identify a router within a VRRP domain. So for example here, we are having a VRID of 1, which is also sometimes referred to as the group, the group ID. So this value can range from 1 to 200 and to 225. Now, the other important thing is what we're calling the virtual IP address. So even though we will configure individual IP addresses here, for example, we've configured 10.1.1.1. Here we've configured 10.1.1.2. When the routers are virtualized, then they're going to use a single virtual IP address. So a virtual router can actually be assigned one or more virtual IP address. So this is actually configurable, as you're going to see when we begin looking at the configuration. Then the other important thing is the virtual MAC address. So the virtual MAC address is generated by the virtual router based on the VRID, as I mentioned earlier. So generally, as I mentioned earlier, the way this is done, let me just write this. The way this is done is that for these bits, it's always going to be like this: 00, 01. Then for the last bit, this is going to be the VRID. So for example, if the VRID is 1, then this is going to be 01 in hexadecimal. So really, that is how the virtual MAC address is actually defined, so that we can be able to reach to the virtual router on layer 2. So that is the basics. That is the basics about this particular architecture. So what happens is that on the host, you're now going to configure it with the gateway address, which is the virtual IP address of the virtual router, as you can see there. So what happens is that this guy is going to actually only see a single router. When a packet comes to this guy, then this virtual router is going to send it to the master. Then the master is going to forward the packet all the way to the internet. So basically, that is how VRRP works. A VRRP state machine is simple, and it's important that you understand them. In VRRP, we have only 3 states. The first one is, where is it? Startup and priority. Oh, okay. So the first one is initialize. Initialize. The second one is master. And lastly, we have backup. So when you talk of initialize, this is the initial state before we establish VRRP sessions. Now, when we establish VRRP sessions, we are going to send what we call a control packet, or something like an advertisement packet in OSPF. So you send that particular packet, and in that packet, you're going to also share your priority with the other routers in the network. So that is what happens. So from initialize, you can either become a master, or you can actually become a backup. You see here we have priority not equal to 255, but this guy has the highest priority because the priority ranges from 0 to 255. So that's the last one. Now, if you shut down or disable VRRP on your router, then you can go back to the initialized state. Now let's understand the master and the backup state. As I've already mentioned in the previous slide, master forwards data, then this one performs the backup role. So how then do we choose between a master and a backup? So when the priority in the received packet is greater than your own priority, then you automatically switch to the backup. Now, we can also transit from backup to master in certain circumstances. So, for example, you can see here, we are switching from backup to master. So we have 3 circumstances when this can be possible. Number 1 is that when the master down interval expires. So what that means is that the master has gone down, so we've not received an update packet from the master for a certain duration of time. The other one is when the priority in the received packet is equal to 0. When the priority in the received packet is equals to 0. So when this happens, this can happen, for example, if you disable VRRP on the master. So when you disable VRRP on the master, it will immediately send a VRRP packet with a priority of 0, meaning I've left the group. So that these ones can now elect a new master. So that is what happens. And that is the scenario where a master can send a VRRP packet with a priority of 0. The last way in which a backup can transit to a master is when the priority in the received packet is less than the on priority. So for example, you configure a new router with VRRP and it has a higher priority than the current master. So that again will trigger a backup to master switch over. So that is it about the state machine. Now let's look at, we have 2 ways in which we can implement VRRP. So we have one of the modes is what we call the active and standby switchover, where you have one router forwarding data, then the other router or routers are acting as backup. So that is what we call active standby. Then you can also have load balancing, so that the other backup routers do not lie idle. Then you can also configure VRRP load balancing. Okay, so let's see how this then is achieved. Okay, so the working process of VRRP standby switchover. Now, this happens, as I've already mentioned, when one router is then acting as the master and the other router is acting as the backup. So in the configuration, for example, we are configuring this particular router with a higher priority compared to router B. So the other thing we have to configure is the IP address of these physical interfaces, and also configure a virtual IP address. So both of them have the same virtual IP address. So what happens here is that any traffic from this particular network is going to be forwarded via the master. So that means that this particular guy is just going to be idle all the time. So that is what we call the active standby mode. Now, as I've already said, the election really is based on the priority. The election is based on the priority. So the router is going to compare the priorities of these 2, and then the one with the highest is going to be elected as the master. Now, what happens then when routers have the same priority? Now, when this happens, then the IP address the IP address of the routers are actually compared. And as you might have already guessed it, the device with the larger interface IP address then is elected as the master. Now, to maintain its status as the master has to periodically send what we call VRRP advertisement packets to advertise its configuration. For example, the priority and also the running status. So anytime that the master, for example, is, or the backup routers are unable to receive this advertisement packet for a certain period of time, then elections will have to occur again. The other time when elections can occur is if, for example, you delete this particular router from that particular VRRP group. So the router will send an advertisement packet with a priority value of 0, as I just mentioned. So again, when the backups receive an advertisement from the master with a priority of 0, they'll just know that this guy has left the VRRP group, and therefore elections will occur again. So the master backup switchover does not happen immediately. It happens after what we call the master down interval timer, which I want to give you as a reading assignment. So please read about the master down interval timer so that you understand what it entails. Okay. So as you can see, initially, each router will send advertisement packets to the other router. So when you receive an advertisement packet that has a higher priority, then automatically you become backup. And the other router with the highest priority becomes the master. And as you can see, then traffic is going to flow via the master. So to maintain the status, the master will periodically send advertisement packets to other devices in the group to notify that it works properly. So if the master fails, what happens? If the master fails, what happens? So let's look at that. So you see, periodically we are supposed to be sending the advertisement packets. Now, what if router A fails? Now, when router A fails, the backup does not then receive the advertisement packets from the master within the master down interval. So it actually immediately becomes the master. It immediately becomes the master, and therefore traffic is going to be sent via router B, and it's still going to be sending the advertisement packets. Okay. So what is happening here? Just a moment. When the original master fails, derivative switching is as follows. Okay, so what happens? What happens when router A comes back to functioning? So what will happen is that router A will also send the advertisement packet. So router B will see that, hey, router A has a higher priority. So when router A finds the priority, in packets received from router B is lower than router A, then router A immediately preempts to be the master. So actually the election in VRRP is preemptive. So when this guy comes back up, then that happens. Now, which problem may occur when the master is preempted immediately? So as you already know, traffic was being sent via this particular guy. Now, if the preemption then is done immediately, what are some of the problems that you think can occur when the preemption is done immediately? What are some of the problems that you think will occur? So the problem, for example, that can occur is on the convergence time of other routing protocols. So if you switch immediately, then you might actually have data loss because other protocols might not have converged in order to forward traffic via router A. Now, VRRP also has several challenges. So the question here is, which failure point may cause a VRRP active standby switch over? So let's understand this scenario. So as you might already have noticed, we configure VRRP on this particular interface that are on the same segment. So what happens is that each of these guys is going to be sending the control packets. Election is going to be done. One of them is going to be to the master, the other one the backup. Now what we are asking is which particular point, when which particular point fails, can we then detect that the master is down? So is it point A, for example, point B, or point C here? Which point? So the answer is if this guy here goes down, then we cannot receive the control packets, the advertisement packets from the master. If the router itself goes down, we are not going to receive the advertisement packets. But with this particular point, with this particular connection between router A and this our egress router that is connecting us to the internet, if this point fails, VRRP will not be able to know that the master is not in a position to forward packets. VRRP is not going to know that. So we might actually have packet loss because this guy is still the master, still sending control packets, so still sending control packets to the backup, and the hosts are still sending their packets via that particular gateway. But what happens when this guy tries to send to our egress router, finds that, oh, this particular link is actually down. So you see, that can actually cause data loss. So how then can some of these things actually be handled? Okay, so we're going to look at that through what we call VRRP Association. VRRP Association. So the solution to the preceding problem is that VRRP Association can be configured in order to monitor the uplink interface or link fault and perform the active standby switch over. So that is the solution for detecting a failure on the uplink. We have to configure VRRP Association. Now this is VRRP Association will be able actually to detect the status change of the interface that is not enabled with VRRP. So we've said that when we are configuring VRRP, we configure it on that interface and this interface. So on the other hand, these two interfaces have not been configured with VRRP, this one and this one. And that's why it's hard to detect when they go down. So with VRRP Association, then we can actually be able to detect if either of these uplink interfaces status changes from up to down. So that is why then we configure VRRP Association. So as you can see, the master will be sending the control packets. If that link goes down, what happens? This guy is going to continue sending the VRRP packet asserting itself as the master. But this guy is not able then to access the internet because the uplink is actually down. So what happens is that the uplink is down, but the master and backup exchange packets normally, and no switching is performed. So consequently, the host access is abnormal or unavailable. So I've already told you then the solution to that. Now, other than the active standby mode, VRRP can also be implemented in what we call the load balancing mode. So how is this performed? So as you can see from the slide, as you can see from this animation here, all hosts are going to forward traffic via the master. That means that the master might actually experience congestion, while the backups are simply going to sit idle. So this is not a very appropriate configuration scenario. So then we can then configure what we call load balancing, because this guy is just idle. So when you configure load balancing, then some hosts are able then to use the backup. So you can configure different VRRP groups so that, so how we do that, how we configure load balancing is simply creating different VRRP groups so that router A is the master for group 1 and router B is the master for maybe group 2. So what happens is that we configure host C with the gateway address of group 2, for example, and we configure these two hosts with the gateway address of group 1. So that is really how then we are able to configure VRRP in what we call load balancing mode. Okay. So okay. So this is what I was saying. So what we do is we configure two groups in each router. So group 1 and group 2, group 1 and group 2 on both routers. Now let's focus on the virtual address. So the virtual address for group 1 is 10.0.0.10. The virtual address for group 2 is 10.0.11.11. So we can actually see that host A and host B have been configured with the gateway of group 1. In group 1, the master is actually router A, while router B is the backup, as you can see here. On the other hand, host C has been configured with the gateway of group 2. So we can see that group 2 actually uses .11, and in group 2, who's the master? So router A is the backup, while router B is the master. So how do we determine who is the master and who is the backup? By simply configuring and playing around with the priority. Okay. So now let's look at basic VRRP configuration. So let's begin with the active standby mode, how to do it. So in this particular example, we want this guy to be the master and this guy to be the backup. So router A to be master, router B to be backup. So all traffic is going to pass through router A. We are going to configure it with a VRID of 1, meaning the group ID is 1, and the virtual IP is going to be 10.0.0.10. So how we configure router A, for example. So let's begin with router A. So we're having router A up to here. So we have to go into the interface G001 that is connecting our network segment. Of course, we configure an IP address as usual. After we've done that, then we need to configure VRRP. How to do that is we use the command VRRP VRID1, meaning that it's group 1. Then we assign it a virtual IP address like that. Then, because we want this guy to be the master, we configure it with a VRRP priority higher than 100, which is the default. So we configure this with 120. Then we can also choose the preempt mode and the delay. So before you preempt, you have to delay for 20 seconds. Then we can also configure what we call track interface. So track interface is used to actually monitor the uplink. So you see here, we are tracking this particular interface so that in case the status changes from up to down, so if this changes from up to down, what do we want to do then? We want to reduce the priority of this particular router by 30. So the command is VRRP VRID1 track interface gigabit Ethernet 0/0/0, then reduce 30. So when we reduce 30, this is going to fall below the default, which is 100. So that means that then the backup is actually going to be the master. Is going to be the master. So configuring the backup is very easy. You simply use this command on the particular interface. So you have to go into that particular interface, G001, then use the command VRIP, VRRID1, VRID1, then virtual IP 10.0.0.10. So if this interface goes down, then this guy is going to be the master because we've not configured a priority here. So the priority by default is 100. So if the priority of router A is reduced by 30, then router B is going to be the new master. Okay, so that is it about that mod. The next part here is what we call the load balancing mode. The load balancing mode. So in the load balancing mode, we want some traffic to be forwarded via router B and some traffic to be forwarded via router A. Solution is to create different groups. So we create group 1 and group 2. In group 1, we make router A master. In group 2, we make router B the master. So remember, these virtual routers have to have different virtual IPs. So for group 1, it has a virtual IP of .10. For group 2, it has a virtual IP of .11. So that you configure the end devices with different next hops, with different gateway address. So this one is going to be configured with .2. This one is going to be configured. These devices are going to be configured with a gateway address of .10. I'm sorry, I think there's something I said there that is not correct. Okay, I think I'm getting confused a little bit. Okay, sorry. These are simply the physical addresses. These are the physical addresses that we are configuring on this particular interface. But what I'm saying is, for host A and host B, for them to forward via router A, you have to configure them with the gateway address 10.0.0.10. For host C, for it to use router B, you have to configure it with the gateway address of 10.0.0.11. So how do we then configure this particular setup? So let's look at router A, how we configure router A here. So it's pretty easy. So we go into that particular interface, then we use VRID1 for group 1, then we give it the virtual IP. We set priority to a value higher than 100 so that it can be the master. We can also set the preemption delay, and we can also track the uplink, the uplink, so that if it goes down, so we are tracking this particular link. If it goes down, we want to reduce the priority by 30. So that is what we've done there. We can also configure router B. So with router B, we begin by adding it to group 1. So we use the command VRRP VRRD1, then we give it a virtual address, which will be the same with that. Then after doing that, we configure the second VRRP group. So we configure the second VRRP group. So again, VRRP VRID2, then we give it a virtual address. We configure a higher priority so that this guy can actually be the master for group 2. Then we enable preemption. Then we can also track the uplink and reduce the priority by 30 in case this goes down. There's a command that they didn't do here on router A that is actually supposed to be done. So in router A, in order to ensure that router A is also able to form a session on group 2, we also have to configure the command using the command VRRP VRID2, like that. Then virtual IP 10.0.0.11. So I think this might have been forgotten or was cut out, but you're supposed to configure this on this interface, so that it can be the backup. It can be the backup for group 2. Okay. So that is the end of this particular chapter. So we have a question here: which of the following statements about VRRP master is false? So the first one is VRRP master periodically sends VRRP packets. Is that true or false? So that is true. We've already said that VRRP master uses a virtual MAC address to respond to ARP request packets carrying the virtual IP address. So that is also true. We looked at the virtual MAC address. So when the devices want to send packets to the virtual gateway, they have to also be able to communicate via layer 2. So they have to send ARP request packets with the destination address of the virtual IP address, so that they can then attain the virtual MAC address. So that is true. And the VRRP master forwards IP packets destined for the virtual MAC address. That is also true. The other one here is, even if the master already exists, the backup with a higher priority will preempt to be the master, even if the master already exists, and then preemption can actually be done. So is this true or false? Depends again with how you have done your configuration on this particular one. Okay. So thank you very much. Asanteni sana. Let's do the next topic.